Hello there, welcome to this class. In this session, we shall be looking at measurement of heat. This will be the part 1 of this topic. In subsequent videos, we hope to continue from where we stop in this video. So, we start by looking at what heat is. Heat is also called thermal energy, and it is a form of energy that flows due to temperature difference. When there is a change in temperature, there is heat flow, usually from a hot body to a less hot body. Just like every other forms of energy, the unit of heat is joules. Now, when heat is added to a body, usually there is a rise in temperature. And when heat is removed from a body, there is a decline in temperature. So, it has been proven that the quantity of heat a body receives is a function of the mass of the body, the mass m of the body, the temperature difference, and the nature of the material the body is made up of. That relationship is a linear relationship, direct relationship. Now, mathematically, it can be represented as Q, which is the quantity of heat, is equal to mc theta 2 minus theta 1, which is change in temperature or temperature difference. Now, where C is the constant of proportionality, otherwise called specific heat capacity. Mathematically, C can be expressed as Q over M times temperature difference. Of course, that is because from here, if we make C through the formula, we arrive at this. And the SI unit of heat capacity is joules per kilogram per Kelvin. By way of definition, specific heat capacity is the quantity of heat required to raise the temperature of the unit mass, yes, a unit mass of a substance through a degree rise in temperature. When we hear specific in physics or engineering, we are looking at per mass. We're looking at what happens per mass. So if you look at the formula here, you're dividing by mass. So that's very important to take note of. When you hear specific, anytime you hear specific, you are referring to the quantity per mass. So it is the heat required to raise a unit mass, alright, through a degree rise. Usually the degree rise is measured in Kelvin in temperature. So in our relation here, we say that the quantity of heat depends on the nature of the material. Therefore, the specific heat capacity for different materials are not the same. And there are textbooks and literatures where you find lists of these values for different materials. But for water, which is very common, the specific capacity is 4,200 joules per kilogram per Kelvin. For copper, 400 joules per kilogram per Kelvin. And then we look at what we call heat capacity. Heat capacity is the quantity of heat required to raise the unit temperature of a body through 1 degree rise in temperature. And the formula is capital C, which is the heat capacity, is equal to mass times C, where C here, small c here, is referring to the specific heat capacity. So if we go back to our formula, we're now multiplying this by M. That means M will be out, and so we're going to have Q over theta 2 minus theta 1 to be our heat capacity. So let's take some examples. What quantity of heat is needed to raise the temperature of 20 kg of aluminum through 10 Kelvin? What quantity of heat is needed to raise the quantity of aluminum, raise the temperature of 20 kg of aluminum through 10 Kelvin? Of course, we know that our formula quantity of heat is MC times change in temperature. So the change in temperature here now is 10 Kelvin. From standard tables, the heat capacity, specific capacity of aluminum is 900 joules per kilogram per Kelvin. Usually you'll be given a question, and then the mass is 20 kilograms. So Q, putting into our formula, 20 times 900 times 10, it gives you this, and then this is your answer in standard form. Look at this also. What is the heat capacity of 20 kilogram of brass, given that C, which is specific capacity, is 380 joules per kilogram per Kelvin? Of course, we are given just two variables there. The mass is 20 kilogram, and the specific capacity is 380 joules per kilogram per Kelvin. We have been told that its capacity, capital C, is equal to mass times specific capacity, small c. So that will give us several 1,600 joules per Kelvin. So that is where we're going to stop this class, but in the future class, I'm going to look at how we measure specific capacity of a solid. How do we determine the specific capacity of a solid? There are three methods that we'll look at in the next class: by transfer of heat, by method of mixture, by electrical method. We're also going to be looking at what we call latent heat, latent heat of fusion, vaporization, specific latent heat, as the case may be. But for now, it's goodbye. Thank you.